So, I just sat in on Supermicro's Storage Summit a couple of days ago, and in today's video, I'm going to summarize some of the stuff that actually caught my interest. I understand from the session that this is the first time Supermicro have done a storage-specific session of sorts, and I mean, it's quite interesting. I knew they made servers and OEM hyperconverged boxes, but I wasn't aware that they had quite a variety of other offerings when it came to storage. The summit was supported by Intel, Nvidia, Scality and Nutanix as well, jointly presenting some of those sessions. Some of the topics at the summit included areas around AI, high-performance computing or HPC, hyperconverged, scale-out storage solutions, and high-capacity storage. But as mentioned earlier, I'm only going to be selectively talking about certain topics, but if you're keen to view all the other stuff at the summit, I believe the recordings will still be online for a while, so I will leave the links below so you guys can check it out. In the AI and high-performance computing breakout, Supermicro showcased some of the latest server storage offerings for this specialized use case. The server model, it's a bit long, so I will not spell it out. I'll probably leave it in the links below. But just a suggestion, Supermicro, perhaps a shorter name in the future and something a little bit easier to remember. Anyway, why are these boxes cool? I'm not too sure if you guys have heard of the latest drive form factor, the EDSFF, which stands for Enterprise Data Center Small Form Factor. It's also known as the ruler form factor. I mean, we are all very familiar with the 2.5-inch small form factor or SFF and the 3.5-inch LFF drives, but man, these EDSFF stuff are tiny. As its name suggests, it does look a whole lot like a ruler, hence it's also called the ruler form factor for some. Not only that, today you can get them in up to 15.36TB per drive. The Supermicro server I'm talking about is a 1U rack mount server and is capable of loading up to 32 of these drives in a single chassis. If you do the math, it is close to half a petabyte of storage in 1U. These are crazily dense boxes with performance to boot. What are the potential use cases? So Supermicro shared in the session about how these boxes can be used in AI deep learning for, say for example, facial recognition type use cases. The need to store millions of high resolution image and have them train AI at a very high speed. I can also see how these boxes will be very good fit in content delivery networks and high performance computing environments. How about the enterprise and the everyday general purpose enterprise type workload? A little of an overkill to be fair, but if the price point are right, these super dense systems can save a ton of power and cooling, and potentially licenses when it comes to hyperconverged type setup that requires deep storage. So the big question though is, will the EDSFF drive be a flash in the pan type device or the future? So Supermicro also shared a chart that highlights the adoption of various drive form types in the data center today. It seems from the chart that 2.5 SFF will continue to be dominant in years to come. But the M2 form factor will slowly give way to the EDSFF as the next high performance tier. In case you're not familiar with M2, it's similar type of drives that you will find commonly used as boot drives in some server vendors and some consumer workstations and laptops as well. They also shared in this session a JBOF device. What the heck is a JBOF? In case you're old like me, you have probably heard of JBOTs, which stands for just a bunch of drives. JBOF is really just a bunch of flash. I will not attempt to spell out the model number again, but I'll leave the links below if you are interested. At a glance, it looks just like any ordinary server, but JBOF's main use case is to extend an existing server's storage capacity by directly attaching to it. Because it's directly attached, the JBOF doesn't have any CPU or memory. It leverages the CPU and memory from its host, and if you look at it, it's really like high performance external drive in some ways. Having said that, it comes with 16 mini SAS connectivities in the backend, and you can have it attached to 8 different hosts. The drives are populated via 2 front-end slates, each connected with an umbilical cord so it can be pulled out and hot swapped. Each slate is consisting of 16 NVMe drives, giving a total of 32 NVMe per chassis. Assuming each NVMe drive is 32 TB each, that's almost 1 petabyte of storage in a 1U form factor. From a performance standpoint, Supermicro is claiming that it can perform random reads up to 13 million IOPS at 0.5 millisecond latency. For those who have seen my other videos, I'm not a big believer of hero numbers, but just for the sake of hero number comparison, 13 million IOPS from 1U is playing in the range of traditional SAN storage. Pretty impressive. Use case wise, I think it is similar, largely targeted at high performance workloads or computing, content delivery networks, and top of the rack big data storage. Just saying it out loud, top of the rack storage feels odd because historically, every time we mount a storage system, we want it at the bottom most. So switching gears, the other interesting topic that was discussed was NVMe-OF, or NVMe over Fabric. As it is, we already have quite a few protocols in storage, with Fiber Channel and iSCSI, and so why do we need this new protocol? Well, it used to be the case that the storage was the bottleneck and there was plenty of headroom in the network. As we get faster drives and with NVMe, we now have the reverse scenario where the network is the bottleneck. In order to alleviate that, not only do we need to have faster networks, we need a more efficient protocol, hence NVMe-OF. Essentially, NVMe-OF is a protocol wrapper that encapsulates NVMe commands natively and sends it across the network. Because it is native NVMe commands, it is built for high performance efficiency and the host connected to it thinks it's a local NVMe drive. As for the network, it isn't just any Ethernet network. The transport will be RDMA, and if you know DMA, which stands for Direct Memory Access, RDMA is really just the remote version of that or the network version of it. In a nutshell, RDMA allows I/O to bypass the entire TCP/IP stack and sends data directly to the devices, reducing the CPU utilizations and the overheads. That's where NVIDIA comes in. So NVIDIA presented a short session on their capabilities on the RDMA network side of the fence, but I'm not going to cover too much in depth, perhaps the next round. So coming back to NVMe over Fabric, it does actually open up quite a bit of opportunities, especially with composable systems. Think of composable systems as the next generation blade systems, but without the limitations. By reducing the storage limitation that often plague compact systems like Blade, you can now have ultra low latency storage and ultra high performance sitting in a network beyond the Blade chassis and performs just like internal storage, and not to mention petabytes of it. Some vendors that are already actively selling NVMe over Fabric solutions today are the likes of Accelero, a software-defined block storage solution, and Weka.io, which is a super scalable file system that is often a popular choice in HPC. I know this is by no means a full-on recap of the event per se, but hopefully it gives you a snippet of some of the exciting stuff that Supermicro is working on. I do think that Supermicro has some pretty cool innovations, and I also like the fact that they always seem to break the mold and come up with cool new ways to do stuff. Too bad the current pandemic meant there isn't any way I can check this out in person, but still nice to know what's on the horizon. Again, if you want to check out these recordings, I've left the links below. Just one final message: if you enjoy the content, like the video, leave a comment, subscribe, and I'll see you guys again next time.